Hello everyone, we're going to be talking about ions. We're going to use Bohr diagrams to show what is going on. Now if you missed our virtual meeting or you just want to review this lesson very quickly instead of that whole big meeting, this is the spot. Okay, so what I'm going to do is I am going to go through the slides. I will pause at the end of the slide, and that might be your cue there to pause the video so that you can get down the note if you need it. Okay. All right, so Bohr diagrams of ions. So noble gases, they don't form compounds because they have 8 electrons in their outer orbit, okay, in their outer shell. So you can see right here, they have a stable octet. There's 8 electrons in the outer shell. So that means they are stable, all right, and they do not react. When elements form compounds, changes occur in the arrangement of the electrons in the outer orbit. Electrons are gained or lost so that elements can have a stable electron arrangement of the closest noble gas. Ions are formed when elements gain or lose electrons. In other words, it will completely fill their outer shell with electrons. That is the goal, is to become stable. In order for a compound to be stable, it must have a completely filled outer electron shell, aka our stable octet. Just remember, octet, oct, like octopus, oct means 8. Okay, so it needs to have a full outer shell. It needs to have 8 electrons. All right, so we're going to look at the arrangement of outer shell electrons of metals and nonmetals. So metals, they tend to have 1, 2, or 3 electrons in their outer orbit. And it requires a lot less energy to lose 1, 2, or 3 electrons than it is to gain 7, 6, or 5 electrons. Now remember, our metals are to the left of that staircase on your periodic table. So it'd be a good idea to bring out your periodic table and take a look at it. So all of the metals are on the left side of the periodic table staircase, those metalloids, okay? Besides hydrogen. Remember, hydrogen's the outlier. They lose electrons when they combine with other elements to form positive ions, and we call those cations. So basically what happens is an electron is negatively charged. So when you lose an electron, okay, you're losing that negative charge. It's going away. It's going to attach to a different atom, okay? So since you've lost that negative charge, you become more positive, okay? And you turn into a cation. If you want to think about it this way, cats have paws. So a positive ion is called a cation. So when they lose electrons, okay, they have a full outer shell, okay? They have the same electron arrangement as the closest noble gas. So their entire orbit now is full because that electron is left, and then it goes down to the next orbit, which is already full. So here's my example of a metal ion. So we're going to look at sodium. Okay, it's in group 1, so it means it has 1 valence electron. And you can see from the Bohr-Rutherford diagram, it has 1 electron here. So it's a lot easier to get rid of that 1 electron, to lose that negative charge. So then it comes down to this orbit, which is full and stable. Okay, so how we draw an ion is these brackets. Okay, we put the charge up here. So since we're losing 1 electron, we put a 1 and a plus, because now this ion, okay, is more positive by 1 because we've lost 1 electron. So now the sodium ion has a full outer shell because we lost this 1 and we've gone down to this orbit. Okay, so it becomes more positive because we've lost a negative electron. Now, an easy way to tell what type of ion an element will become is to look at your periodic table. So if we look at sodium here, in the top right here, you can see what type of ion it's going to turn into. It's going to turn into a cation because it's positive, and it's going to have a 1 plus. So it's going to lose 1 electron. If I look at magnesium here, the charge is 2, so I'm going to lose 2 electrons. And it's in group 2, so I know that there's 2 valence electrons. So those 2 valence electrons are going to leave, and it's going to become more positive. Okay. Nonmetals, okay, they tend to have more than 3, okay, in their outer orbit. So they have 4, 5, 6, or 7 electrons. And it requires less energy for nonmetals just to gain 1, 2, or 3 instead of losing 7, 6, or 5. Okay, so it's a lot less energy just to gain a few electrons than to lose a whole bunch. So what happens is they gain electrons, and when they're gaining electrons, they're gaining a negative charge. So they form negative ions, and we call those negative ions anions. So since they're gaining those electrons, okay, their outer shell now, their outer orbit is going to become full and stable, just like the next closest noble gas. So my example is fluorine. So fluorine is a nonmetal. It's on the right side of the periodic table, the right side of the staircase. Okay, it's in group 17. So remember, when your group number is bigger, you take the 17 and you minus 10, and that tells you it has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. So it's a lot less energy just to gain 1 electron to become stable, to have 8, than it is to lose 7. So it gains 1 electron, and now it has 8 on the outside. And since it's gained 1, it becomes an ion. So we do these square brackets, okay? And then we put the charge here. Since it gained 1, it's now 1 negative is the charge. And you can tell, again, by looking at your periodic table what type of ion, or what the charge would be on that ion. So let's look at the periodic table again. Let's find fluorine, which is up here. So you can see fluorine, its charge, if it becomes an ion, okay, is 1 negative. It's going to gain 1 electron. It's going to gain 1 negative charge. All right, so for this homework, we're going to do the first 10. And that's going to be easiest. Okay, so you're going to draw the first 10 ions of the periodic table. If you get to group 18 elements, they don't form ions at all. So all you have to do is just write the element symbol. Okay, so let's do an example here. Let's keep that. Let's do a couple examples. All right, so why don't we let's do a nonmetal. Let's do magnesium. Okay, so magnesium, when we look at our periodic table, magnesium, okay, it's got 12 electrons. It's in the second group, so I know I'm going to have 2 valence electrons. And I can see here that it's going to lose 2. Okay, so I think for this assignment, it's probably a lot easier if we just do the Louis dot diagrams. So basically, if you remember, our Louis dot diagrams only care about the valence electrons. So here's the Louis dot diagram of magnesium. Okay, and we're going to turn this into an ion. Okay, by looking at our periodic table, we know it's going to have a 2 plus charge. These 2 are going to leave. Okay, so we're going to put 2 here. And since they're going to leave, we're going to become more positive because those negative electrons are leaving. So these 2 electrons are going to leave, and we're going to go down to the next orbit. Okay, so I'm just going to use a different color. So we're going down an orbit. So in our next orbit, let's get a different color. Red's okay. So we're going to go down to the next orbit, which is full. It has 8. Okay, and this is our ion. This is a cation. Okay, and this is our magnesium ion. All right, let's do a nonmetal now. Let's take a look at the periodic table. Let's do phosphorus. Okay, so we know it has a -3 charge. Okay, we know what our ion is going to be. It has 15 electrons. It's in group 15, so I know that it's going to have 5 valence electrons in the outer shell. So let's put our positive here, our P. Okay, it has 5 valence electrons. Okay, and this is going to be forming an ion. Now, since I have 5 here, okay, I know I need 3 more electrons. All right, so I'm going to put 3. And since I'm gaining electrons, gaining that negative charge, my ion's going to be negative. All right, so when I gain 3 electrons, I'm going to have 8 in the outer shell. And now it's stable. Let me call this an anion. Okay, so just remember, in group 18, when we look at group 18, which is right here, you can see there's no charge. It gives you no indication of what that ion's going to be because they're already stable. They already have a full outer shell, so they're not going to turn into an ion. So when you're coming across for the first 10, when you get to say helium or neon, all you have to write is just the symbol and move on. Okay? All right, if you need any help or you have any questions, just send me a message. I'll be happy to help. Have a good one.